Hello, everyone. Welcome to my talk on integrating DevSecOps with HashiCorp. My name is Anu, and I'm a Google Cloud lead at Cognizant. You can connect with me on Twitter or LinkedIn as per the details on the screen. The traditional security models were primarily designed for a different era of software development, where deployments were infrequent and architectures were relatively static. These models typically involved a distinct security team that operated independently from the development and operations team. The traditional model had a reactive nature. The traditional security was largely reactive. Security teams would often only engage after software development was complete or even after a security incident had occurred. This approach led to delays in identifying and mitigating vulnerabilities, as security reviews were performed late in the life cycle, often just before deployment or after a threat was detected. The security measures under traditional models were slow to implement. Changes in security policies or the integration of new security tools could take weeks or even months, largely due to in-house processes. This delay was aggravated by the need to ensure compatibility with legacy systems and processes, which often were not designed with agility or flexibility in mind. Security was a separate entity, siloed from development and operations team. This separation often led to a lack of communication and collaboration, resulting in misunderstandings and misaligned objectives. Security requirements would often come as bolt-on additions rather than being integrated throughout the software development process. Increased vulnerabilities, late detection of security issues meant higher risks of vulnerabilities being exposed. Rectifying security issues post-development or post-deployment is significantly more costly than addressing them during the design and development phases. To overcome these challenges, the industry has moved towards integrating security as a fundamental aspect of development and operational processes. The shift aims to make security proactive, fast, and an integral part of every phase of the development lifecycle. A transition to DevSecOps is not just beneficial, but necessary for modern software development and infrastructure management. It adopts the shift-left philosophy, integrating security from the earliest stages of development for faster, more proactive protection. DevSecOps is not just about adding security tools in the development pipeline, but about changing the culture to include security as base part of the development and operational processes. It is the integration of security processes within the DevOps process. The development, security, and operations overlap and interact under DevSecOps, emphasizing on collaborative efforts where teams work together to anticipate potential security issues and address them proactively. The main goal of DevSecOps is to embed security as a shared responsibility throughout IT and the lifecycle of software delivery. Shift security from being a final checkpoint to an integral part of the development process. It does a faster delivery that reduces delays caused by security issues discovered late in the development. It enhances the security and resilience of applications by addressing vulnerabilities early on. The use of infrastructure as code in modern development environments has allowed teams to manage and provision infrastructure through code, which can be version controlled and reviewed, just like application code. This makes it easier to integrate security into the infrastructure from the onset by codifying security policies and compliance standards. This reduces human errors and increases the responsibility of secure environments. Let's look at how HashiCorp tools like Terraform, Vault, and Consul automate and secure infrastructure provisioning. Terraform is used to create reproducible and predictable environments by defining infrastructure as code, incorporating security settings directly into the provisioning scripts. Vault helps manage secrets and protect sensitive data within automated pipelines, ensuring that security credentials do not get exposed. Consul, on the other hand, is used to automate network configurations with security-first approach, ensuring secure communication between services. To demonstrate how Terraform is used to create reproducible and predictable environments on hyperscalers like Google Cloud Platform, here is an example where we provision a Google Compute Engine instance with some of the security settings defined directly in the Terraform scripts. This example includes the creation of a VPC, Virtual Private Cloud, firewall rules, and a Compute Instance Engine or Compute Engine instance. Now, HashiCorp Vault plays a very important role in managing secrets and protective sensitive data within automated deployment pipelines, crucial for maintaining the security integrity of both software and infrastructure. Vault acts as a centralized platform to securely store and tightly control access to tokens, passwords, certificates, API keys, and other secrets. By centralizing secrets, Vault minimizes the spread of sensitive data across multiple environments and systems, reducing the risk of unauthorized access or breaches. One of Vault's powerful features is the ability to generate dynamic secrets. Dynamic secrets are generated on demand and are valid for a strictly limited duration. This means that each time an application or service requires access to a resource like a database or an API, Vault generates a unique set of credentials for that particular session or task. These credentials are then automatically revoked after the predefined time limit or the session ends, significantly reducing the risk of secret leakage. Vault seamlessly integrates into existing DevOps workflows and CI/CD pipelines. This integration allows automated systems to securely fetch configuration details and secrets as needed without human intervention. The process uses APIs and built-in authentication methods like tokens, Kubernetes authentication, IAM, etc., to ensure that only authorized systems and processes can access the secrets. Vault provides detailed policies that dictate who or what can access specific secrets. These policies can be configured with great precision, ensuring that only the necessary personnel or systems have the appropriate level of access to secrets. Vault also keeps detailed logs of all the interactions with sensitive data. These audit logs include information about who accessed what secret and when, providing a traceable record that can be crucial for compliance and security auditing. Vault can encrypt and decrypt data without actually storing it. This allows applications to encrypt their data using Vault's encryption services and then store the encrypted data elsewhere. This service is used to secure data at rest and in transit, providing an additional layer of security by ensuring that sensitive information is always encrypted when stored or sent over networks. Now, let's consider a scenario where a deployment process requires database credentials. In this process, first step would be to configure the pipeline. The CI/CD pipeline is configured to request database credentials from Vault as part of the deployment process. At deployment time, the pipeline authenticates with Vault using a predefined method like CI/CD token and requests the credentials needed for accessing the database. Vault dynamically then generates a username and a password for database and sends these credentials back to the CI/CD pipeline. The pipeline uses these credentials to access the database and perform necessary operations like migrations or updates. After the deployment or after the time limit expires, Vault automatically revokes the credentials, ensuring they can no longer be used. HashiCorp Consul is a versatile tool primarily known for its service delivery capabilities, but it also provides significant features to automate network configurations and enhance security within service networks. Consul provides a centralized service registry that allows services to register themselves and discover other services via a DNS or HTTP interface. This discovery mechanism allows services to communicate with each other without hard-coding IP addresses, which can frequently change in a dynamic environment like container orchestrators or cloud platforms. By decoupling services from their network locations, Consul enhances the flexibility and reliability of the system. Consul can automatically issue and renew TLS certificates for all the registered services, enabling mutual TLS across your entire network. With MTLS, both the client and server verify each other's identities before initiating communication, which prevents unauthorized access and ensures that data transmitted across the network is encrypted. This setup is crucial for maintaining confidentiality and integrity in communications between services, especially in public or shared networks. Consul Connect is a feature that provides service-to-service connection, authorization, and encryption without requiring changes to the application code. Connect leverages Consul's service discovery and configuration capabilities to enable secure communication between service using sidecar proxies. These proxies intercept service communication automatically, applying security policies and encryption defined within Consul. This means that all communications are secure by default, adhering to a zero-trust network model where trust is never assumed and must be verified. Consul can automate network configurations by managing access rules and routing policies that dictate how services communicate with each other. For example, Consul can configure dynamic firewalls and load balancers based on current network conditions and service registry data. This ability ensures that network settings always align with the actual state of the service architecture, enhancing both security and performance. Consul also continuously checks the health of services and automatically updates the service registry and network configurations in response to the changes. This feature ensures that traffic is never routed to the failed or compromised nodes, enhancing the overall resilience and security of the application infrastructure. Now, consider a microservice architecture where each service needs to securely communicate with others over a potentially hostile network. Each service registers itself with Consul, including metadata such as service name, address, and port. Then we enable Consul Connect. Enable Consul Connect to issue TLS certificate to each service, setting up sidecar proxies that will handle inbound and outbound connections for the services. In Consul, then we define intentions that specify which services may communicate. For example, you might specify that a payment service can only receive traffic from the order service and not from any other service. As services are registered and deregistered, Consul then automatically updates the network configurations such as firewalls and load balancers to reflect these changes based on predefined policies. When a service needs to communicate with another, its sidecar proxy checks the intentions defined within Consul. If the communication is permitted, the proxy establishes an encrypted MTLS connection with the destination services proxy. By using Consul in these ways, organizations can automate their network configurations while implementing a robust security-first approach that ensures secure and efficient communication between services, regardless of the underlying infrastructure. This setup is particularly advantageous in dynamic and scalable environments where mutual configuration and maintenance of security settings and network policies could be complex and very error-prone. Now, enhancing security posture using automation and compliance. We use Terraform to enhance security policies and compliance standards across all the environments. Leveraging Vault to handle secrets dynamically, reducing the risk of exposure and ensuring credentials are always current and revocable. Utilizing Consul for encrypted, authenticated communication between services, ensuring the integrity and confidentiality of data in transit. So all these three services come together to provide a very secure and holistic solution for the environment. Thank you.